Good morning, students.
Good morning, ma'am.
Uh, Good morning. We have started in our last class the chapter on computer organization and design, basic computer organization and design. We have done with instruction codes, computer registers. Today we will look at computer instructions. Can anyone quickly tell me what are computer registers, how many are there, and what are their names? No one can tell? Computer registers, DR, AC, IR, PR, INPR, OUTR, AR, PC. 8 registers we learned. And also general purpose registers R1, R2, R3 and so on. In this topic of computer instructions, we will look at what are the different instruction formats in a basic computer. There are basically 3 kinds of instruction formats. First is known as memory reference instruction. Second one is known as register reference instruction. Third one is input output instruction. We know that instruction is used to specify to computer what operation it should perform. And that how we are doing? There is an opcode and there is an address. What we learned so far is this kind of instruction, which is known as memory reference instruction. From the name, you can determine that it is an instruction that refer a memory, and memory location is referenced through this instruction to perform particular operation, and that address can be indirect or direct, that is mode bit. Well, we know that an instruction is 16 bits long. Out of the 16 bits, in memory reference instruction, 12 bits are for address. Because it is apparently referencing memory. So memory address is required. Three bits for opcode, operation code, and 1 bit for mode, which is specify whether this address is a direct address or indirect address. This is memory reference instruction. There are other 2 types of instructions, which are register reference and input output. What do you mean by register reference instruction? This is an instruction format in which the operation is performed on the data stored in the register, not in the memory. Here, memory reference instructions specify that an operation will be performed on the data stored in the memory. Here, memory is our primary memory, which is RAM. Register reference instruction states that an operation would be performed on register. Register, as you know, is a part of processor. Within the processor, there are several different kinds of registers, and operations can be performed on those registers. Input-output instruction is the third kind of instruction wherein operations would be performed on the I/O, input-output. You know input-output operation. What are input-output operation? We can read the data from keyboard. We can write the data onto monitor. Such kind of operations are specified in an instruction known as input-output instruction. A question arises now. How are you going to distinguish between these three types of instruction? There is only one instruction register which is having 16 bits. Can you tell me how to distinguish between these three types of instructions?
Ma'am, depending upon the mode bit.
Um, this mode bit, are you talking about this 15th bit?
Yes, ma'am.
15th bit, yes, you are partially right.
Hmm.
15th bit is also used to determine the instruction kinds. But observe here, there is another way to distinguish among these three instruction types. This is right. This is partially right. Half answer is right. Another half answer I need.
Ma'am, on what operations we are performing that?
Yes, very good. That opcode is there, no? Yeah. Where the operation means opcode. This opcode also determines these three bits are there, no? 12 to 14. These three bits also determine the type of instruction as well as this mode bit also. How that we will look at uh, in this. I think there is a flow chart. Let me quickly look at the contents. This anyway we will learn later. In this flowchart it is clearly explained, but then now I would explain briefly how it is done. This opcode 3 bits values when they are from 000 to 110. 3 bits means we get 8 different combinations. What are the combinations we obtain if there are 3 bits? We obtain 000, 001, 010, 011, 100, 101, 110, and 111. These are the 8 different combinations when there are 3 bits. 3 bits of opcode to the power of 3 is equal to 8. The range is 0 to 7. When the opcode comprises of values from 000 to 110, for these, how many are they? How many are these? These are 7. 1, 2, 3, 4, 5, 6, 7. Their range is from 0 to 6. If the opcode comprises of these values from 000 to 110, it is a memory reference instruction. What is left over now? Leftover value, binary value is 111. This 111 is used for RR and IO. This is for MR. Is this point clear? First, what I'm trying to say is this 3 bits, opcode bits, they are 3 in number. Because they are 3, we obtain 8 combinations. And from these 8 combinations, when the value begins from 000 to 110, it is a MR instruction. MR means memory reference instruction. Whereas when the binary value, opcode value is 111, it can be register reference and IO. Now can anyone tell me how to distinguish between whether it is RR or IO? Because both of them have 111 and 111. Opcode is same.
Depending upon mode bit.
Yes, very good. Now comes the mode bit. Yes, very good. Now to distinguish between RR and IO, you have got this 15th mode bit. This mode bit will decide whether it is RR or IO. If it is 0, it is RR. If it is 1, it is IO. The opcode for both remains 111. There is another question now. MR, memory reference instruction, are of 2 kinds. We have direct memory reference instruction and indirect memory reference instruction. The question then arises is, how do you distinguish between them? Can anyone tell me how do you distinguish between them?
Ma'am, if the mode bit is 0, then it is direct.
Yes, very good. Here,
And if it is 1,
yes, if
then it is indirect.
yeah, here if it is 0, it is direct. It is 1 means it is indirect. You look at here, this 0 and 1 alone cannot identify which kind of instruction it is. Essentially, we have opcode that determines the kind initially and later mode bit would determine. Next, another question arises. What is another question? Here in memory reference instruction, 12 bits are used to specify the address and what operation is to be performed on the data stored in the address is known from the opcode. In RR and IO, there is no opcode essentially. Well, here what happens is we have got 111 in both opcode position. How do you now know which operation to be performed on the register? Can anyone tell me where it has to be specified? Where it has to be specified? What
Opcode, ma'am.
opcode? There is actually in opcode we have got 111. No, in both RR and IO, opcode contains value 111. Where do you specify
Yeah,
the? Yes.
maybe it is the kind of operations that we are performing.
Yeah, where? But we have to specify without telling the computer, it can't do it. For every operation, there is a code. Without specifying the code, how will computer do the way to specify the code? That is my question. Where to specify? In memory reference instruction, we are specifying within this opcode bits 12 to 12, 14. In
And then it
ARA,
is mode bit.
no, mode bit is only for
Okay,
distinguishing
okay.
between the types of RR or IO. Can anyone make a guess? What do you mean by instruction program, Sirisha? Okay, you just pay attention here. When you are talking about memory reference instruction, it is essential to specify the address. Is it needed to specify the address in RR and IO? There is no need actually. There is no need to specify the address in RR and IO. Therefore, in the place of address, you um, you put up the operation code in place of this. From 0 to 11 bits are there, no? Total 12 bits. These 12 bits will carry operation code in RR and IO. Here you see it is register operation, here you see it is IO operation. Okay, students, here these 12 bits specify the operation, and these 3 bits specify the uh, instruction type to be RR or IO. And then when you put up 0 at 15th bit, it boils down to RR. Here there are 12 bits for operation. 111 remains same, and when there is 1, it means it is IO. Okay. Don't worry, as we study further the topics, you will get more clarity. These are the basic computer instructions. This is a hypothetical computer. Hypothetical computer means what? We are creating it. It may not exist. We are imagining and creating. So there are these 7 operations, and they have got both the symbols, which is nothing but the mnemonic. We call these as mnemonics. And they have also got the uh, code. It can be binary code or it can be hexadecimal code. As you all know, instruction register is 16 bits long. Its length is 16 bits. If you have to specify these 16 bits in binary, it would take more space. You have to uh, mention all 16 bits. If you put these 16 bits in the form of hexadecimal, then how many bits you have to specify? Can you tell me? This is binary length, 16 bits. If you convert this binary into hexadecimal, how many bits you obtain in hexadecimal? 16 bits of binary is converted to, students, think and tell me. No one can say.
8 bits, madam.
No, not 8. How 8? Why do you say 8? Okay, the answer is 4 bits. Why 4? The question is why 4? You know that 4 bits of binary is equivalent to 1 bit of or 1 symbol of hexadecimal. Hexadecimal has got uh, 16 symbols in it, 0 to 9
8
and
bits.
A to F. Okay, so these are 10 and 5, 15. How do you represent 15 in binary? All ones, 4 ones. This is 15. 8 plus 4, 12. This is 13, 14, and this is 15. You need, for one hexadecimal symbol or digit, you need 4 binary bits. For one hexadecimal digit, you need 4 binary bits. So whenever I tell you to convert binary to decimal or to hexadecimal, the shortcut is you divide by 4 for hexadecimal. Okay, if it is 32, divide by 4, you get 8 hexadecimal digits. If it is 16, divide by 4, you get 4 hexadecimal. You look at here, this is 0 and XXX. What are these 3 XXX? 3 hexadecimal digits. This is hexadecimal code. This 3 and this 0. Total 4 hexadecimal digits. So when you convert this 4 back to binary, how many you obtain? 4 into 4 is equal to 16 you obtain. Students, are you able to understand? Is it making sense to you all what I'm explaining now?
Yes, ma'am.
So remember that 4 binary bits is equal to 1 hexadecimal digit, and 1 hexadecimal digit is equal to 4 binary bits. And is one operation. When I hear these are memory reference MR. These are MR instructions. They are 7 in number, right? So MR instructions. First one is AND. What is its uh, code? AND is all zeros. When I is 0, I is 0 means it is direct address. You get 0 in the all 4 zeros. In here I am now writing the instruction register contents. Instruction register has got 16
Bits.
yeah, very good, 16 bits. Out of the 16 bits, 12 bits are address. Okay, these 12 bits are address. So these 12 bits you are representing as XXX. Okay, these 3x denote the address. It can be any address of the memory. And this 0 means these 3 opcode 0 and this 3 is opcode and this 0 is direct address mode bit to denote direct address. This is for AND. So AND opcode is 000. And what is add? Add means this would be 001. Add is 001. This is 0, 0, 0. And for this column denotes for direct address because I is 0. This is for direct, and this is for indirect because I is 1. In memory reference, we have two kinds, direct and indirect. And these are the codes. 2 means 0, 1, 0. 3 means 0, 1, 1. 4 means 1, 0, 0. 5, 1, 0, 1. 6, 1, 1, 0. What I told you, please recall that memory reference instructions are from 000 to 110. Well, we obtained the same here, 000 to 110. Okay, understand, students?
Yes, ma'am.
And now let us look at the description. And memory word to AC means in memory. Here I am drawing. This is our memory. This XXX denote the address. That one you are performing AND operation and with the contents of AC. This means that AND operation is performed between contents of AC and memory word. Whatever is stored in this memory, it is known as memory word. Even it can be a numeric value, a text value, whatever, but we call a memory word. So this is memory word, and this one is accumulator contents. Both are ANDed. Add means add memory word to AC. AC is accumulator. Load memory word to AC means from memory you load into AC. Store content of AC in memory. From AC you store it into the memory. Branch unconditionally. What do you mean by branch unconditionally? Here you have sequence of instructions. Let me give you an example. Just when I was explaining you the memory, this basic computer instruction formats, I have branched. Branch means what? Jumped. Jumped to directly to that flowchart by skipping all this. By skipping all this content, I went to that place, that page. So that is what that is known as branching from this instruction. Say it is instruction 1, 2, 3, 5, and 6. You are at instruction 2 and you skip 4, 5, and jump on to you skip all 3, 4, 5, and jump on to 6. This is known as branching. Alright, and then when you are branching unconditionally without any condition, when you branch it is BUN. When you branch and save return address, what does it implies? You go to a place by skipping the succeeding or subsequent instructions, and then you record where you have to come back, and then you save where you have to come back. When you are jumping from 2 to 6, you have to come back to 3 because the instruction 2 is completed its execution. Next instruction to be executed is 3. Essentially, what you have done here is you have jumped, you have branched. by leaving 3. So after you finish the work here at location 6, you go back to 3. That is branch and save return address, BSA. Increment and skip if 0. Increment the value, whatever data you have, you increment the value of the data, and then if it is 0, after incrementing, if it is 0, you have to skip the next instruction. Okay, skipping the next instruction and moving to uh, the instruction after it, the subsequent instruction to the skipped instruction. That is IESZ, increment and skip if 0. AND, ADD, LDA, STA, BUN, BSA, ISZ. These are memory reference instructions. These you can use in direct mode as well as indirect mode. These are RR instructions or RR operations. RR means register reference operations. And what are they? CLA, it means clear AC. And what is the opcode? 7800. Where do you place this opcode? You place this opcode in the first 12 bits. Alright. First 12 bits will receive the opcode for RR and IO. Opcode is 7800 and uh, operation is CLA. CLA means clear the contents of accumulator. CLE means we have learned when we studied about the common bus system that there is an extension bit E attached to AC. CLE clears that E bit. It's like a flip-flop. E is a flip-flop that can store only a single bit that is attached to accumulator. CMA is complement AC. If AC contains value of 1011, when you state CMA in the first 12 bits, that is the RR operation code, they get converted to 0100 because it is complementing. CME is complement E. CIR is circulate, write, AC and E. It is shift operation. You have AC and you have E. So what you have to do? You have to perform right shift operation in a circular mode. Means the value of E will come into AC and this bit will travel to move to E. Likewise, you can perform this type of circulatory left operation as well. And CIR, CIL, INC is increment. SPA is skip next instruction if AC is positive. If AC means AC register has a positive value, skip the next instruction. SNA is skip next instruction if AC is negative. SZA is skip if AC is 0. SZE is skip if E is 0. HLT means halt. Halt is what? Stop. You stop this process, halting the computer. Going ahead, we have these instructions that correspond to IO. What are IO instructions? Their codes are mentioned in the second column. These code will be uh, provided in the first 12 bits of the IR register, means instruction register. What are the symbols? INP means input character to AC. From keyboard, you take it and input into AC. OUT, output character from AC. Take from AC and supply to the monitor. SKI, skip on input flag. If there is an input flag, skip the next instruction. Skip on output flag. ION means interrupt on, IOF interrupt off. These we will study anyway in detail as we uh, go along. But basically, what are instructions? Are you all clear with that?
Yes, ma'am.
Any doubts? If you have any doubts, you can ask. Before going ahead, I want you to. AC means accumulator. AC is a register. We learned, no? Different types of registers. AC, PC, AR, IR. Instruction set completeness means the, the the different set of the different instructions or set of instructions, they are said to be complete if computer includes sufficient number of instruction for each category. What are the categories? Arithmetic, you should have sufficient number of arithmetic instructions, logical instructions, shift instructions, and instructions for moving memory, for moving information to and from memory and processor registers, program control instructions, which means this branching and jumping, input output instructions. These are the four categories of different operations or instructions in a computer system. Timing and control, okay, we will look at timing and control only. Otherwise, I thought of completing this instruction cycle. It is very huge. So let me complete that timing and control. In tomorrow's complete class, we will study instructions cycle, which is quite important. We are saying that a processor performs arithmetic operations, logical operations, shift operations, and now we learned about program control operations. And operations are to transfer memory from, to transfer data to and from memory and processor. These all operations are performed, but when they are performed, the question is when. When operations have to be performed. All right, let us take an analogy. You have got subjects, theory subjects, you have got labs. In your first semester, you are going to study so many different topics. But which subject or which course to be studied when? How it is determined? Can anyone tell me?
Ma'am, first the basic subjects will be taught, then their next version will be taught to us.
Okay, that is in the order of. Is there any disturbance in my voice?
No, ma'am, it's clear.
Sirisha, uh, perhaps network problem at your end. Are all students able to hear me clearly? Okay, what you said is right. It okay, thank you. Uh, Sirisha, check your network connection. Uh, if, each course you go in the order of basics to advanced. That is very right. This is with respect to each course. With respect to all the courses, when to study which course, how, that is determined by. Now at this time which subject is to be taught, at this time which subject is to be taught, how do you know? Because of timetable. You get timetable, right? Timetable is
Yes,
the one that controls your entire day at college.
yes, ma'am.
Yes. When you when you come to college, first thing you are given is the timetable. When you receive timetable, then you arrange your books accordingly. You arrange your meeting with the friends according to that. If there is a class at 9 o'clock, CA class, then you prepare yourself for as per the timetable. So timetable is controlling your study, your course of study at your college. And what is the one that is controlling all these operations in a computer system or specifically in a processor? It is control unit. All right. Control unit is the one component within a processor that controls the timing of all the operations when what is to be performed. The timing for all registers in the basic computer is controlled by the master clock generator. There are clock pulses which are applied to all the flip-flops and registers in the system. Okay, every flip-flop and register has got clock pulses. If this is a register, it receives a clock pulse, and this clock pulse generate timing signals, and all this is done in a control unit. And this clock pulses generate control signals, and these control signals are generated in the control unit, and these control signals provide control inputs for every electronic component, which are multiplexers, decoders. All components receives control input through the common bus, you know to the processors and uh, processor registers, and therefore all the micro operations in within the accumulator or any other register for that matter is controlled by this control unit through control signals, which are control inputs, which are connected to every register and every flip-flop and every unit, every component. This control unit can be designed in two ways. One is hardwired. Control unit can be designed in two ways. One is hardwired. Another one is um, control micro programmed. Another one is micro programmed. Hardwired control unit means uh, all um, these timing signals, they are coded in hardware. They are arranged and they are put in the form of hardware, in the form of cables, wires, and all. Whereas micro programmed control unit is about having a micro program, means a program that controls and that generates the control signals. Hardwired and microprogram. In hardwired, control logic is implemented with gates, flip-flops, decoders, and other digital circuit. Hardwired organization, control logic is implemented with gates, flip-flops, decoders, and other digital circuits. Okay. If I have to give you an example, mm, this control unit has got some flip-flops and decoders and some gates like this AND gate, OR gate, and all. These are hardware, right? These are hardware parts. These hardware parts are arranged in such a manner that the control unit would generate the control signals as per this format, which has been developed by using these hardware components. The control signals would be generated. It means it is fixed. It is fixed in nature. You cannot change this because it is uh, hardwired in hardware. Can you make changes in the hardware? In the hardware, you purchase your computer. Can you open the processor and can you include a new gate or a new wire or a new decoder? You can't do that. For to do specialized devices are required in labs. It is performed all that hardware related stuff. In other words, we can say that these physical components are fixed. Their programming means physically they are connected and all those connections are fixed. That's why it is known as hardwired. The advantage of this is it is quite fast. Why it is fast? Because it is directly coded or hardwired. It is directly wired into the hardware, and doing anything through hardware is obviously fast compared to having a program and executing it. When you write a program, it takes more time because a program has to be compiled or interpreted and then executed. All that takes several steps in between writing and execution. Whereas if it is in hardware, it takes very less time because directly it can be executed. So it is very fast. Did you understand this, students? Any doubts in this? Microprogrammed in control unit, there is a control memory. In the control memory, there is a program. Program means it is a software. You might be writing program in Java or in C language. What is that? That is software. That's not hardware. So you write a program and store in control memory, and then program gets executed and generate control signals. With an analogy, what I can tell you here is, if you have your timetable, if it is carved on a wooden board, okay, on wooden board, you ask a carpenter to design your timetable on that board. Okay. Here at 9 to 10 some class, 10 to 11 some class, like that he will do with the wood only, with using his all instruments. And then that board would be fixed in the department. Okay. So whenever student come and note down that and then follow that, teachers also follow that. But then suppose timetable has to be adjusted or it has to be changed. Can you do, can the teacher do that? Can the administration do that? No. Why? Because they require a carpenter. Because he is specialized to do that. And it is very difficult, to do all that work. So this is like hardwired. And what microprogrammed analogy would be a timetable you are creating using software, MS Word. Suppose you are using Word and creating, or you are using paper and pen and you are creating. If you use paper and pen and then you put up the timetable, after 1 week, if you feel that it has to be changed, you take another paper and then you design new timetable. It is quite easy. This is microprogram. Is the analogy clear, students?
Yes, ma'am.
Hmm. This one is now the control unit. This control unit is which one? Is it hardwired or microprogrammed? Can anyone tell me?
Microprogrammed, ma'am.
Where is the program in this? Do you see any program, any control memory? What I told you is um, in microprogrammed control unit, there is a control memory and there is a control program. Do you see control program or control memory in this?
No, ma'am, no.
What do you see in this?
Control unit, decoders.
You see decoders, you see gates, logic gates, and also you see sequence counter, decoder. So, what we have learned? We have learned that a hardwired control memory would have gates, flip-flops, decoders, and other digital circuit. So, from this figure, what do you understand? This is which kind of control unit? Yes, this is which
Hardwired.
kind? Hardwired. Very good. This is hardwired control unit. Why? Because it has got decoders, logic gates, and some other, uh, so, here other components, the sequence counter, decoder. This all make up this hardwired control unit. This hardwired control unit, how it operates, we will look at in tomorrow's class. And what about all students? Please let me know about the status of your assignments.
Ma'am, completed, ma'am.
Oh, very good. Others, very good. So Vani has completed, Sai has completed. Are you finding any difficulty in writing assignment? Are you,
No, ma'am.
are all the topics clear?
Clear, ma'am.
Very good. So now Very good. So I think almost all the students have done the assignment. If look, students, it will be decided. Actually, offline classes have started. It will be decided